GM everyone. Super excited to be here once again. I think we'll just give it a little bit more time. I'll say like 2 minutes for other people to join, and then we can, okay, then we'll just kickstart. Awesome. So yeah, today we'll be looking at Oracle integration, right? So over the past few sessions, we've been looking at, how to build your first decentralized application. And quite a number of us, sort of like went through how to build your first decentralized application. In this case, we built prediction markets and also took a look at how to use Kaia SDK to build a mini explorer. I hope that was a fun journey for everybody, right? And so today we'll be looking at how to make our smart contracts more hybrid and extending it to more functionalities in the real world, right? So this brings us to Oracle integration, all right? So let's take a look at today's agenda, right? We'll be looking at oracles and why do we need them in the blockchain specifically, right? We'll be looking at types of oracle and also the different classification based on their data flow, based on their trust model, and also based on the different classifications. We'll get there in a while. We'll also look at use cases, right? And also decentralized oracles on Kaia, right? As a blockchain, to make your smart contracts, more hybrid and connect to the real world, you need to integrate decentralized oracles. And on Kaya, we have quite a number of decentralized oracles to help you make your smart contracts hybrid. And afterwards, we're going to, go straight into building, right? We'll be building out a dynamic NFT that uses Oracle network in this case, and to get the price feed of a particular asset. And then the dynamic NFT reacts to the changes in the price of the asset, right? All of this I'm going to explain when we get to each of the sessions. So without further ado, let's jump into what are oracles, right? In simple terms, oracles refers to any type of service or protocol that provides decentralized system, especially smart contracts, access to external data sources, legacy systems, and advanced computation. Now, you can think of Oracle as a bridge that connects the blockchain world and the real world, right? Just like every other bridge that connects a particular end to another end, your blockchain oracle connects your blockchain world to the external world, in this case, real world. Now, why is this super important? This is super important because of the blockchain oracle problem. In itself, blockchains are isolated, meaning that all of the data, all of the all of the actions happening are all embedded within a particular network. And as such, it doesn't have access to the external world. Now, this isolated feature of the blockchain is what makes it secure because all of the nodes, all of the validators in a blockchain have access to the same data. Take, for instance, somebody wants to send Kaya from user A to user B. Before we validate that transaction, every node in the blockchain, because it's isolated and the same data exists on every blockchain node. Every blockchain node is going to check, does this user have enough balance to send to user B? If yes, then it is going to send the Kaya to the user B. And if it doesn't have enough balance, it is going to fail. Now, this isolated system is what makes blockchain secure because every node have the same information. And also with smart contracts, it is deterministic, meaning that for every input, there's an expected output. So in this case, you expect that when you transfer Kaya from user A to user B, you expect that the balance of user A should be reduced and the balance of user B should be increased, right? This is what we mean by deterministic. When there's an input, there's always an expected output. Or when you try to interact with a particular blockchain protocol or a dApp, right? It is expected that when you click the mint function, for example, you are expected to get an NFT minted to you. This is what we mean by deterministic. Now, all of this put together, right, the deterministic nature of smart contracts and also the isolated nature of blockchain is what we call the blockchain oracle problem, because blockchain in themselves cannot pull or push data out of the blockchain, or smart contracts in themselves cannot pull data out from the external world. Now, this is where oracles come in and act as a bridge to connect the blockchain world to the external world. I hope that makes sense. Now, a practical example of this is, take for instance, let me look for somebody in the chat. Take for instance, myself and Eric, we are trying to bet on who is going to win the Ballon d'Or, right? Myself, I say that Lamine Yamal is going to win the Ballon d'Or, and I put down 50 Kaia in a smart contract. And Eric says that, oh, Lionel Messi is going to win the Ballon d'Or. Now, if we put this in a smart contract, because of the blockchain oracle problem, how does the blockchain fetch the actual data of who won Ballon d'Or? Now, this is a question. Now, with the help of oracles, we can connect your smart contract to external data sources like sports results or Ballon d'Or results, and your smart contract can now fetch this data in themselves and then execute whatever type of action. Now, in this case, for our scenario, we say that if Lamine Yamal wins the Ballon d'Or, then I should be paid all of the money staked in the contract. Now, if Lionel Messi wins the Ballon d'Or, then Eric should be paid all of the money staked in the contract, right? So this is fully powered by oracles. Now, with oracles, our smart contract can be fully hybrid, right? Meaning that it now taps data from the external world, and it can now do much more stuff, right? It can now perform much more use cases and much more functionality. How would that make sense, right? Moving on, how do blockchain oracles work, right? 1 minute. Now, how do blockchain oracles work? Now, we said that blockchain oracles they act as a bridge, right? Connecting the smart contracts of the blockchain world to the real world. I hope that is cemented. Now, how do they work? Under the hood, the first thing they do is they listen, right? Just like every other oracles or for every other scenario, you have to monitor the blockchain for any incoming user requests, right? So they listen if a particular smart contract is trying to request for an off-chain data. This is what they first do, because this is how they are triggered, right? So they listen to monitor, or they monitor the blockchain network for any incoming user request for off-chain data. The next thing is, when there's a user request, they extract, right? Um, Extraction is basically fetching data from multiple sources, right? Because we want to be able to get, in our scenario, Ballon d'Or results, right? We can either get our results from football.com, go.com, or whatever platform that provides this data, right? So once the oracle listens, the next thing they want to do is to extract. They want to extract the data from multiple sources. Now, after extracting, they want to also format this data into blockchain readable formats, right? In this case, take for instance, the endpoint that they are using sort of like returns a type of format. The oracles want to convert that into a blockchain readable format such that the smart contracts can easily consume them. Now, the next part after formatting the data source or the data results is to validate. So validation basically means that, oh, the oracle actually got the correct data, and this is not a false data. Now, this is a way for you to prove on chain that the data that you got is from a reliable source. So every oracles need to validate their data results on chain, and this is done by generating a cryptographic proof and basically just sending them on chain. And the next thing after validating is to compute, right? Computation in this case is for scenarios, especially for generating random numbers, right? Random numbers in this case can be used for various scenarios. We'll see that in the next slides, right? So when we need to perform off-chain computation like random numbers or like advanced mechanisms or computation, oracles basically helps us compute them off-chain, especially for random numbers. Now, if in the case where it's a random number, it basically computes. If it's in the case where it's a price feed or sports feed, after listening, extracting, formatting, and validating, it basically just broadcasts the data on chain, right? So this is literally taking the data that you have sourced and bringing them on chain for the contract to consume. Now, in any case, there are two scenarios here. A contract can either request for a data from off-chain. When I say off-chain, it basically means the outside world, right? Off-chain in this case means the outside world other than the blockchain network. So a smart contract can either request for data off-chain, right? Or send data on-chain, or send data from itself outside to the blockchain, right? Now, this means that in a case where we want to, from a smart contract, trigger a payment off-chain, that means that the smart contract has to transmit a data from itself outside to the blockchain world. Now, in this case, this is where output comes in. We'll get to the various types of oracles in a while, right? How that we have inbound and outbound oracles, right? And this would basically explain the concepts much more better. So this is literally how blockchains work under the hood, and I hope that makes sense, right? The next on the list is this image that sort of like explains all of the process. Now, as you can see from the any input, it basically listens to the request and plugs into any external API or data source. Then this request is being validated, right? And then sent to the blockchain in this case. Then from the blockchain, if it's a case where it's an outbound oracle or the smart contract wants to send information from within itself to the real world, right? The smart contracts can also send information out to the blockchain oracle, and this oracle sends them to wherever they want them to be, right? So this is the simple analogy for all that I've been explaining for how oracles work, right? As you can see, it aggregates data from external sources. Then this data is being validated and broadcasted on chain via the oracle nodes. Then the smart contract consumes them, and then if it's a case where the smart contract has to transmit data out, it also does that using the Oracle nodes, and then it transmits it to the external source, right? So pretty much about how Oracle works. Now, the next on the list is what are the various types of blockchain oracles? So for this session, we are going to be classifying the various types of oracle into various parameters. The first on the list is data source. Now, is the data coming from a software or an hardware, right? That's the first thing that you want to classify your blockchain oracle as. We said that they get data from the external world. Now, is this data coming from a software, either an external API or an online database or whatever, or an hardware, whether from a physical device or from a sensor, right? And the second classification is based on the data flow. How is the data moved on chain? Is it a pull-based method or a push-based method? What is the trust model? Is it a centralized oracle or a decentralized oracle? For the most part, a centralized oracle only has one single entity where it fetches data from, while a decentralized oracle has multiple, data sources, and these data sources are being aggregated. Now, we also have the direction of communication. Does it provide data into the blockchain or transmits data out of the blockchain? Now, this was where I mentioned inbound or outbound type of oracles. Now, it's important to note that a particular oracle can be a mix of all of these four components. So an oracle can be a software oracle, a push-based oracle, a decentralized oracle, and an inbound oracle. So it's a mix of all of these various components and classification. All right, so moving forward, let's explain them one after the other. All right, so for data source, we have software oracles and hardware oracles. Now, when we say software oracles, it means that it depends on software APIs and digital system, right? And also for hardware oracles, it depends on physical world devices or sensors. Now, where does the data come from? Either from web APIs, servers, or online databases for software oracles. And for hardware oracles, its data comes from IoT sensors, barcode scanners, um, radio frequency identification chips, and also cameras. These are all hardware devices, right? The type of data that is being gotten. For software oracles, we have weather updates, sports score, stock prices, and asset prices, like I mentioned previously. But for hardware, we want to be able to get temperature, motion, GPS location, and all of those things, right? So for the most part, you might have scenarios where you want to build a proof of location type of smart contract. So you need your Oracle to be able to provide you access to a GPS location, right? Um, Awesome. So the next part is the example use cases, right? What are the example of the various use cases that can be built with software oracles? We have decentralized finance, prediction markets, which we talked about in the previous session, also gaming. While for hardware, we have supply chain tracking, agriculture, and proof of location. Now, supply chain tracking is basically you just tracking a particular goods from production to delivery, right? For the most part, you can attach FRID chips into your product, and with the help of hardware oracles, you can basically, confirm their availability or their status on chain, right? That's that about data source, right? For data source, the type of oracles is classified into two: software oracle and hardware oracle. The next one is data flow, right? How is the data moved on chain? Now, for this data flow, it's of two types: push-based and pull-based. Now, when we say an oracle is push-based, it means that it basically reports on-chain data or oracle data on-chain at a predefined cadence, right? In this case, what it means is that it push data on-chain practically depending on a particular at bit rate or deviation percentage. Now, what is at bit rate? This is time in seconds. Or you might say you want your Oracle to be pushing an update to the smart contract or on chain every 10 seconds, right? So it continually push an update to the smart contract or on chain every 10 seconds. That's the at bit rate, right? The next part is the deviation percentage. Now, you can also set that, when there is a significant change in price or a significant percentage change in price, take for instance, if the asset price moves up by 10% or the asset price moves down by 10%, then push this data on chain. So this is the idea behind push-based Oracle. For pull-based Oracle, what it does is that it computes your off-chain data, or it computes data for you off-chain at every subsequence, and the data is only sent to the blockchain when it's being requested, meaning that once the data is being computed off-chain, the smart contract pulls this data in itself based on when it's needed, right? Compared to push-based Oracle, where it's automatically, continue pushing the updates on chain based on the at bit rate or the deviation threshold, right? And so this is the major difference between a push-based Oracle and pull-based Oracle. Now, for a push-based Oracle, it is always available because it is updated at regular interval. For a pull-based Oracle, it is not available until explicitly requested. Now, I mentioned that it basically computes off-chain data, right? Um, Off-chain, and it is only when it is needed, that is when it is being requested for. And so this sort of like makes sense for latency sensitive application like on-chain perps, real-time trading, because you want to be able to get the current price of your asset that you're building on or whatever asset type that you're building on. And while for push-based Oracle, example use cases are lending platform, insurance, and also liquidation system. I hope that makes sense. Moving on, we also have trust model. Now, for trust model, it's basically categorized into two: centralized Oracle or decentralized Oracle. Now, when we say something is centralized, it means that it relies on a single entity for data. And trust me, when we rely on a single entity for data in the blockchain world, there's every tendency for single point of failure, right? Because it's only relies on a central data source for getting data, right? Now, for decentralized Oracle, it relies on network of independent nodes, right? And so, as such, it is prone to single point of failure. Now, the next part is aggregation. Because we rely on a single source of data, we can basically aggregate data for centralized oracles for accuracy. But in the case of decentralized Oracle, because we use various independent nodes, we can aggregate data from many sources just to verify how true this data is. Now, example use cases for centralized Oracle is it can be used for internal enterprise apps or for off-chain trusted environments. Now, for corporations such as, take for instance, IBM or Coca-Cola that is into supply chain, they can use this type of oracles, right? While decentralized type of oracles are what powers DeFi, Rails, insurance, prediction markets, and also high value dApps. I hope that makes sense. Moving on. The last part, which is the direction of communication, right? For, like I mentioned, a particular smart contract can either send data or send requests from itself to the outside world, right? That means that you're pulling data from off-chain on-chain. Now, this is what we mean by off-chain to on-chain. But for outbound oracles, we are transmitting data from the smart contract off-chain. Now, what is an inbound oracle used for? An inbound oracle is used for enabling smart contracts to react to real-world events, right? Which makes us build hybrid smart contracts or more amazing use cases for dynamic NFTs, DeFi, prediction markets, and other high-value decentralized applications. While for outbound oracle, it basically helps us to notify and execute actions in external apps, right? Take, for instance, you're trying to trigger a particular payment infrastructure off-chain, but this is dependent on an on-chain action, right? And so outbound Oracle helps us transmit data from on-chain, off-chain, right? I think I did mention the price feed for DeFi, or like the example use cases, how that for inbound, we can use it to build price feed for DeFi, insurance payouts, and for outbound oracles, we can basically trigger off-chain bank payments, send SMS and email alerts. So these are the various types of blockchain oracles dependent on various parameters. Now we started with the first one, which is the data source, software oracles and hardware oracles. Then we moved on to data flow. It can be push-based or pull-based. Then we moved on to trust model. It can be centralized or decentralized. Then we moved on to direction of communication. It can be inbound or outbound. Now, this brings me to the final part again to mention that an oracle can either be any of these, right? It can be it can first be a software oracle, and then a push-based oracle, and then a decentralized oracle, and then an inbound oracle. Now, if you tie all of this together, when you take a look at some of the oracle providers on Kaia, it meets all of these types of oracles or this classification, right? So these are the various types of oracles, and I hope that I've been able to do justice to that. Moving on, it's important to also talk about the use cases. Now we've understood that oracles act like a bridge. Really, really important. If there's anything that you need to take away from this session, is to understand that oracles act like a bridge, connecting the blockchain world to the real world, right? Which means that because of the fact that blockchains are isolated, they don't have access to the external world. Now, oracles makes their connection to the external world possible. Now, if a particular smart contract or blockchain integrates an oracle, what are the various things that can be built? Now, let's take a look at them one after the other. The first is decentralized finance. Now, for quite a number of us, must have heard the word decentralized finance. Now, for those who haven't heard the word decentralized finance, it basically means traditional finance, just like we have it in the real world, but brought on chain, right? Now, you do stuff like lending and borrowing, trading, derivatives, or even liquid staking and all of those trends, right? So the way Oracle sort of like helps decentralized finance is that it provides real-time price feeds and market data to power your lending protocol, your trading app, or your derivative protocol. So because all of these apps are dependent on assets, right? They need a way to be able to fetch the real-time price of these various assets. So oracles basically helps these various trends or these various niche, especially in decentralized finance, to get access to the real-time price of the various assets. I hope that makes sense. The next one is dynamic NFTs and gaming. Now, there are quite a number of like scenarios where, there are quite a number of scenarios where we want to build an NFT that evolves based on a real world scenario. Take, for instance, based on a player score, or based on weather, or based on real world sports data. So with oracles, we can build dynamic NFTs such that it evolves based on the price action of a particular asset or based on a player score. Now, it is dynamic because it can react to external data sources or external data. Now, that is why they are dynamic. Now, also in your game, you might want to fetch a particular player score off-chain and brought into, take for instance, if you're trying to build Dream League on-chain, you would want to get the performance of a particular player off-chain and brought on-chain, right? The next part is insurance, right? Like we all know, insurance is basically protecting yourself against risk. Now, if insurance is brought on-chain, we would want to be able to get real-life data of the asset that has been insured. Take, for instance, if it's a farm, right? We need to be able to get the real world data of a particular farm. In the case where there's crop failure and a particular person insured their farm on chain, we want to be able to get the data of the crop failure on chain. And when we're able to get this data, the insurance smart contract can process payouts, right? So what this means basically is that for insurance, we have access to external data based on real world events like weather, flight delay, or crop failure. And this can be used to like trigger automated payouts for these various use cases. Now, the next on the list is enterprise, right? Like I mentioned, IBM or Coca-Cola might want to also build decentralized, or might also want to be able to integrate oracles, right? And when oracles are being integrated, they can build amazing use cases like supply chain verification, payment triggers, and also compliance reporting. Now, so the last use case for oracles is sustainability. With oracles, we can get environmental data, e.g. for carbon credits and also energy use. So this is basically for dApps that are focused on the green initiatives, right? So if you're looking to build a sort of like green dApp, right, you can basically use your oracles to fetch the carbon credits off-chain and also energy use off-chain and basically bring them on-chain. I hope that makes sense. So these are like the various use cases for oracles in your smart contract. So far, we've looked at decentralized finance, which is basically traditional finance brought on-chain. We also looked at dynamic NFTs and gaming, insurance, enterprise, and sustainability. There are more and more use cases that can be built in any case. depending on how you can implement your oracles or depending on what functionality you're trying to achieve. All right, so that's that for the use case. Moving on. Now, what are the various blockchain oracles that are on Kaia? What decentralized oracles are we integrated with to sort of like bring off-chain data into our smart contract? Now, for the first part, we have Oracle Network, which is like the native oracle on Kaia. We have Pyth Network, we have Super Oracles, and also Witnet. So I want to implore us to take a look at each of these oracle providers and explore their functionalities and how to integrate them. In as much as you have a basic knowledge of smart contracts, most of these oracles provider have documentation that can guide you through. Now, for this guide, we'll be taking a look at Oracle Network, right? Because I think I changed my mind that minute to sort of like use Oracle Network because it's native Oracle network provider on Kaia. And so if you're looking to also explore Pyth Network, right, I think that's one of the assignments. It's basically the same, right? So what are the major services that these Oracle providers sort of like provide? And the first on the list is data feeds, especially price feeds. Now, from all of my explanation, you've seen that I've mentioned that, oh, we can get data off-chain. Take, for instance, asset prices, FX rates, commodities, and so on and so forth, right? So that said, this can be consumed in like DeFi protocols, right? For building either your lending protocol or whether your liquid staking protocol or your trading protocol or your staking app, right? So this is like the major use of data feeds, right? Now, what are the common use cases? I wrote here that stablecoin collateral checks. You want to be able to check if the current USDC rate is pegged to the actual dollar rate. Automated liquidations, on-chain derivatives, real-time asset valuation for NFTs and DAOs, right? So this is one of like the major service that Oracle providers sort of like provide, price feeds. You can get the price of various crypto assets. Take, for instance, Kaia, ETH, Sol, and just name it, right? These oracles have like various assets or price of assets supported, right? So make sure to check that documentation for a list of the asset prices supported. Now the next part is verifiable random function, right? So most times we have use cases where we want to randomize things on the blockchain. Take, for instance, in your games, for loot drops, for rarity, or for randomized trace, or when you want to randomly assign tasks to people or randomly assign rewards to people, or even your consensus mechanism sampling, where you're trying to randomly select validators or committees. Now, we need random numbers on-chain. Now, blockchain oracles helps us to get trusted and provably fair random numbers on-chain. Now, this random number is secure, unpredictable, and verifiable. Now you ask a question that why not use block parameters like block.timestamp, block.difficulty, or block number, right? Now this can be easily manipulated by miners or validators in the case where there is huge financial gain, right? So we don't want to leave or we don't want to tempt our validators to do what they're not supposed to do. And so it's always advisable to use VRFs, right? Which is provided by Oracle providers such as Oracle Network, Pyth Network, Super Oracles, and Witnet. So if you're looking to enable random numbers or randomization in your smart contracts, VRF is the go-to service to use, especially on these Oracle providers. I hope that makes sense. Now, moving on is to actually demo our dynamic NFT. So in the use case, I sort of like explained that we can build dynamic NFTs and gaming. Now, for the sake of those who don't know what dynamic NFTs are, dynamic NFTs are those type of NFTs that evolve based on real-world events. Now, when we say real-world events, it can be reaction to a price change or reaction to a player score or any type of data. Now, in this demo, we want to build a dynamic SVG NFT that reacts to the price of Kaia. So we'll be fetching the price of Kaia off-chain using Oracle Network. And this price is being pulled into our dynamic NFT. And then it sort of like makes our NFT to evolve, right? So when there is price increase, we basically see the happy emoji. And when there is price decrease, we basically see the sad emoji. And if the price doesn't change, we basically see the neutral emoji, right? And the color of the NFTs also change based on certain randomization, right? And so this is what we want to build. But before then, I think that every one of us can uh, go to the Build on Kaia Bootcamp repo, right? We have the sample code posted already, right? So I want to implore us to go to the Build on Kaia repository and basically just all right. So I'm going to be explaining. So I'm going to be explaining the dynamos.sol. No, dynamos.sol is a dynamic NFT contract, right? And I'm going to see how it's implemented. But before then, please, I want us to follow along. Um, I'll be all here, please. I want us to follow along as we code from scratch. Now, this NFT contracts will be using Foundry in this case. So all you need to do is to basically just follow along as we code together. Right, so if you have any questions, if you have any blocker, we can solve it together on the call, hopefully, if there's time, right? And so let me quickly run through the code so we can understand what we are talking about. Now, this is a dynamic NFT contract. First, it imports the OpenZeppelin ERC721 URI storage, which basically helps us to manually customize the token URI for each token ID or for each tokens, right? So with ERC721 URI storage, you can customize the token URI for each tokens. Now, the next part is counter.sol, which helps us to increment our IDs for the NFT, and also base64.sol basically helps us to encode our SVG with our token URI, right? Next on the list is the Oracle contract. Now, this, as you can see, I mentioned I will be implementing Oracle Network price feed. So let's go to Oracle documentation. Uh, all right, so this is Oracle documentation, docs.oracle.network. Now, according to the documentation, it says that if you want to implement a data feed, right, which is to stream off-chain data to your smart contracts, in this case, we can build various protocols such as lending and borrowing, mirrored assets, stablecoins, asset management, options and futures, and much more. Now, for our data feed, right, we have various addresses that's been deployed to Kaia network, either Kairos testnet or Kaia mainnet. Now, as you can see in the docs, it says how to read from data feed. Now, we have the initialization process. Now, if you take a look at our code right here, we have to import this command or this line of code from the Oracle network documentation. And in our contract, we have the same also. Import ifeed proxy from Bison AI Oracle contract. Then in our constructor, we are basically setting the address of the price feed, right? So the address of the price feed is what helps us listen to requests on the blockchain. And so once it listens to the request on the blockchain, it basically fetch, extract, and then broadcast this data back to the smart contract. So this is what the feed proxy does, right? You know, we talked about how blockchain Oracle works. We said it listens, it extracts, then after extracting, it sort of like format, validate, and then broadcast the data back, right? So the feed proxy is what helps us do that, right? And so once that is done, according to what we have here, after importing the ifeed proxy, the next thing we want to do is to initialize the feed proxy address. Now, how do we get the feed proxy address? It's provided here. the Oracle data feed includes various data feeds that can be used for free of charge. So when you click on this, these are the various addresses. I just want to type Kaia USD, right? Because this is what we are using. So Kaia USD, this is for Kairos testnet, and this is for Kaia mainnet. So I'll be copying the proxy, which is this address 0xC2A, right? So as you can see, it has a lot of like price feeds, Jup USDT, Kaito USDT, Kaia Korean won, and so on and so forth. There are a lot of like price feeds, right? And so in our contract, all we just need to do when deploying, we just have to pass in the proxy address. And with that, we can listen to requests in the smart contract and broadcast the request. Now, the next function I want to explain is the build SVG. Now, for the dynamic NFT, we are using SVGs because SVGs are lightweight and can easily be updated. You can easily manipulate an SVG. As you can see, we are randomizing a few colors to be added to our SVG, which is added here. We expect that our SVG color should be either of these colors: red, yellow, green, blue, cyan, gray, and magenta, right? After that, we are basically just concatenating our SVG construction from head to body and tail. Now, once that is done, it returns a full SVG for us that will be used as our dynamic NFT. Now, the next function I want to explain is the compare price, which basically listens or fetches data by calling the get Oracle data feed latest answer. Now, how did we arrive at this? If we go back to our Oracle docs, after initializing our contract over here, we need to be able to read data. Now, to read data, it says that data can be queried from the feed using the following function: latest round data and get round data. Now, to get the answer that we are looking for, that's the price feed, all we need to do is to call data feed.latest round data, and it provides these answers: the ID, the answer, which is the price feed, and updated at. So in our smart contract, we wrote a function to do that, right? If you go down, I basically just destructured it to return the answer, which is the price feed. And here, I'm calling the compare the Oracle to get the latest price feed. Now, what compare price helps us do is to help our dynamic NFT. You know, I mentioned originally that we want our NFT to be dynamic. In the case where the price of Kaia goes up, we want an happy emoji. In the case where the price of Kaia goes down, we want a sad emoji. Now, the compare price is the function that is doing that. It checks for the current price, and if the current price is greater than the last price, the price indicator is up. And if you check, the price indicator is here, right, which is this guy, happy emoji. And also, if the price goes down, price indicator down, we have the price indicator down emoji. And also, if it's neutral, we have the price indicator neutral emoji, which is basically price is down, which is the sad and the neutral face, right? Having said that, also, I think those are like the major functions that we've implemented in our dynamic NFT contract. I hope that makes sense. So this is how to first initialize an Oracle provider in your contract. First, we are importing this interface. Then we are also initializing the interface right here with the price feed address. And then we are calling the price feed address in this function, right? All right, so that's pretty much it. So for each time there's a price change, we're going to call the update SVG. All right, so if we want to check if the price of the NFT or price of Kaia went up, we want to call the update SVG such that if there is a change in price, it basically updates the price, or it basically updates the token URI of our dynamic NFT. Now, in the case where the price goes up, we want our SVG to change to an happy face, right? And if it goes down, we want our NFT to change to a sad face, right? So that's pretty much about our contract. Now let's go straight into, implementing our contract from scratch. Just to confirm, by just typing in the chat. How many of us are following along? Now we have to bootstrap our contract from scratch. So we want to deploy this on Kaia Kairos testnet, right? Using Foundry. So now the next step is to deploy, interact with the contract, and also verify the contract using Foundry. So to do that, you can just go to this Dynamos deployment guide. I've provided the step-by-step guide for you to, follow along, right? So if you're in the chat, oh, awesome. It would be also nice to, follow along or code along as we are going through the session. So the first thing we want to do is to install Foundry. But yeah, let's go to Foundry documentation and see what we need to do. So because I'm a Mac user, right, I basically don't have to install, what's it called, Git Bash. Now it says that if you're using Windows, you need to install and use Git Bash or WSL as your terminal. All you have to do is to, click on this link and download Git Bash and then follow this command, right? Having said that, I'll just go back to this step-by-step guide. Now, okay, awesome. So I would want to bootstrap my project from scratch. Can we all see my screen just to confirm? Oh, great. All right. So I want to bootstrap my project. I'll just open the terminal and install Foundry over here. Um, I hope that we can see this enough, right? All right. So the first thing I want to do is to copy this line of command to install Foundry, right? So I'm going to paste this over here and wait for Foundry to be installed, right? So let me just copy this and run Foundry up. So wait for Foundry to be installed, right? And afterwards, once Foundry is installed, right, we want to initialize a simple Foundry project. So I'll just copy this forge init dynamos, right? That's the name of our contract or our project. So I just do forge init dynamos, right? So this initializes a simple, what's it called now, Foundry project for us. And yeah. So I'll have to cd to my project, cd dynamos, and then open this up on VS Code, right? Uh, all right, so can we see my screen well enough? Or how many of us are currently, or have we been able to also bootstrap our Foundry project? Just to confirm. Blank screen. Oh yeah, yeah, yeah. So this is my uh, current screen. I hope you can see this very well. All right, so just to confirm one more time, can you guys see my screen? Can you reply in the chat so we can move on as fast as possible? Okay, so I want to take the silence as a yes, right? Now, when we initialize our Foundry project, it basically is, bootstrap certain folders. We have the scripts folder, which basically helps us write scripts in Foundry, and also the source folder, which is where you had your dynamos.so contract, and also where you write your test contracts. As you may know, all of your test is written in Solidity for Foundry. And so, yeah, we also have the library folder, which basically stores all of your dependency. And we have the foundry.uml file, which is used to, configure how you want Foundry to behave. Other than that, I think we'll just get started. The next thing to do is to install the various dependencies. If you see in our contract, right, we are basically using, let me open this up in another tab. If you check our contracts over here, we are basically using various contracts, right? Open Zeppelin and also Bison AI Oracle contracts. So we need a way to be able to install that. And so to install all of this, we just need to copy this line of code, forge install. I'm going to install this, right? So this install my Bison AI Oracle, which will basically help me to use Bison AI Oracle contract in my contract file, right? So once that is done also, because I'm also using Open Zeppelin, I want to install Open Zeppelin contract. So while we wait for this to install, all right, so this is done. Oracle installed. The next thing I want to install is Open Zeppelin. Now, having said that, let's wait for our dependencies to be deployed or to be installed. All right, so once they are being installed, we want to configure our contract folder or Foundry to be able to call them. And the way we do that is to use remappings. Remappings is basically telling how we want our contract folder or like the dependencies to be referenced, right? And so we're going to basically create, or in our foundry.uml file, we're going to copy this remappings configuration, right? And basically just paste here. So what this is doing is that it's saying that when I'm trying to reference Open Zeppelin in my contract, just basically use Open Zeppelin, but this is where you can find the Open Zeppelin contract, right? As you can see, if you open your lib folder, which houses your dependencies, we now have Open Zeppelin contract folder and Oracle contract folder, right? Same thing applies here. This is us telling Foundry that if you are trying to look for Oracle contract, this is how it should be referenced, right? So now let's copy our contract code and create a new file called in our source folder called dynamos.sol. So I successfully pasted our contract, right? As you can see in our file, we are saying that this is how to reference Open Zeppelin, and this is how to reference Bison AI, right? As we have stated in our foundry.uml file, right? And so as you can see now, my code is not throwing any error, right? That's the first step. Now the next step is to configure our .env, right, for RPC, because when you're trying to interact with smart contract, you need an RPC, right? So for the most part, I'm going to create a .env file in my root folder, and I'm going to say .env and just paste what I copied from the from this guide, right? So this is us inserting in our .env that we want to use the Kairos RPC URL. So if you want to get various RPC URL, you can go to Kaia docs, right? Let's go to Kaia docs. You can find various RPC providers in the reference, public RPC endpoints, and we have testnet, we have mainnet RPC, and you can just explore. Right after that, once we are done, we want to be able to tell Foundry how to reference our RPC that we set in our .env, right? So this is us. All we have to do is to copy this code and just paste in our foundry.tuml file. So this is us telling Foundry how to reference our RPC endpoint from .env. And afterwards, what we want to do is to import accounts. Now, it's pretty much important to iterate that when it comes to building smart contracts, especially from like a development perspective, most of us use our private key, or we stick private keys in plain text, which is not really advisable because for the most part, some of us lose our funds by pushing your private key to GitHub. And there are a lot of like web crawlers that's sort of like scrape the web for exposed private keys. And you'd agree with me that once a private key is exposed, the hacker is going to just transfer your money out. I think I've seen scenarios of that happen not once, not twice. So just to be on the safe side, it's important to use something called password protected key store, right? In this case, you don't have to stick your private key in your .env. So this is like the most recommended way of building or interacting with smart contracts at the development level, right? So what we have to do is, for the most part, so because I want to import um, my account from Kaia Wallet, I'm going to be using the cast wallet import command. But in the case where um, I want to create a totally new account, all I have to do is just do cast wallet new and the name. Then I have to fund this account and then I start using it. But for this part, I think we're just going to copy this uh, command. And what we want to do is to paste it here. I'm going to name this oxpampam dev 3. All right, so this is going to prompt me to enter my private key. All right, so what I'm going to do is I'm going to go to Kaia Wallet and basically just export my private key. Right, export private key. So I'm going to copy my private key and basically just paste here. Then it's asking me for a password. I'm going to put a password. As you can see, it says that West Pampam Dev3 key store was saved successfully. Address is so and so. So this means that anytime I want to interact with a smart contract or I want to deploy a smart contract, all I have to do is just input my password right now. And with my password imputed, it basically checks for my private key and decrypts the key store, and it basically signs the transaction, right? This is such a way to like avoid putting your private key in plain text and having like a security conscious mindset while developing. I hope that makes sense. Now, having done that, the next thing to do is to compile our contracts, right? Like I've mentioned while working with Remix, after writing your smart contract, you want to compile your smart contract such that it provides you with the API and the bytecode. Now with Foundry, what you can do is to run forge build, right? So we're going to run forge build. This compiles our contract. As you can see, it's using compiler version 0.8.30, right? This is important because we'll be using this compiler version later on in the future. So once that is done, once we've compiled our contracts, now it's time for us to deploy our contract. Now for this case, we'll be using the script method in Foundry. Now Foundry creates two ways for you to deploy a contract, using forge create or using scripts, right? So I'm just going to copy this code and paste in my script folder. As you can see, we have already a bootstrapped script folder already, which is counter.s.sol. So what I'm going to do is just to follow this same method. I'm going to do dynamos.s.sol, right? I'm just going to copy the command there. As you can see, in our counter.s.sol is importing scripts and console from Forge standard library, script.sol, and also the counter.sol contract. So in Foundry, every sort of like interaction from tests to like deploying or writing scripts is done in Solidity, right? And so if you read through this command, this is us initializing our counter contract and the setup function, which is basically run once, and the run function, which broadcasts our transaction locally. And then if there's an RPC provided, it propagates it or it broadcasts it on chain. And so this is it using the new keyword to create a new instance of a contract, and our contract is being created. So the same thing is done in our dynamos.sol, other than we are importing dynamos.sol instead of counter.sol, right? Every other thing remains the same, the script, which is provided by Foundry, of course, because this is what provides us functionality to the script features. Now, we want to also declare the instance of the Dynamos contract and basically just create a new instance of the Dynamos contract. Now, one major change is that in our dynamos.sol, we have a constructor argument, right, which is the address proxy feed, the address of the feed proxy, right? So to do that, we have to pass in the feed proxy address while deploying our contract. And so this is why we have line 15 in this case. I hope that makes sense. Moving on, we also, so once this is done, the next thing for you to do is to run your script command. But first part is to load our .env, or yes, to load our variables in the .env. So to do that, you're going to run the command source.env. And so it's basically providing your terminal access to your .env such that it can easily call the RPC environment variables. Now, to deploy your contracts, all you have to do is to copy this command. Now, what this command is doing is running forge scripts. What chain you are deploying to? In this case, we are deploying to Kairos testnet. And this is the script we are using, dynamos.s.sol, and the name of the script, which is dynamo script. Also, we need an RPC URL. As we did set in our .env and our foundry.toml, then this is the broadcast command, which basically broadcasts our transaction on chain. Basically, and it's basically using the name of our account that we imported. In this case, I'm going to change this to OXPampam dev3. In your case, it can be any name that you did set, right? So I'm just going to copy this command and paste over here. So I'm going to change this to OXPampam dev3 and click enter. So once again, this is compiling our contracts once again. And once that is done, as you can see, it's asking me to enter my key store password. Other than fetching my private key for my .env, all I have to do is enter my password and it can sign transactions on my behalf, right? So this saves us the stress of, pushing private key to GitHub, right? In the case where we refuse to, or we forget to add our .env in our git ignore file. So as you can see, our contract has been successfully executed. The gas price is 50 GUI and the total price is 0.3 Kaia, right? Pretty much we have a new contract address. So I'm going to copy this and check on Kaia scan, right? So let's quickly check our contract on Kaia scan. I hope that we are following along. Oh, great, great, great. And so far, do we have any questions or do we have any blocker? How many of us are following along, like coding along on the spot? Do we have any questions so far? So far, we've created or we bootstrapped our Foundry project. We did set up our env file, our foundry.toml file for remappings and also for the RPC. Then we did set up our script file for dynamos.s.sol. And the next thing we did was to compile using the forge build command. And then the next thing to do was to deploy using the forge script command. Right? And now our contract has been successfully deployed. So let's quickly check Kairos, kaiascan.io, right? All right, so still loading, man. Okay, let's check the transaction hash, right? So this is the transaction hash, right, for our deployment. 3 minutes ago from my address, and the transaction fee was 0.1 for Kaia, right? As you can see in our contract, we did set that in our constructor, we said that we should call the safe mint function to mint our NFT to whosoever calls or deploys the contract. Right? So this means that my address will be sent a dynamic NFT, which is the Dynamos SVG NFT in this case. And so this is what our Explorer is showing us. As you can see, let's take a look at our Dynamos NFT. So right now, I currently have um, my SVG contract deployed. And right now, the current price of Kaia is 0.19. The last time was 0.19875623. Now, it's currently showing the happy face. Now, if the price of Kaia significantly goes up to 0.5 or 0.3, it still shows the happy face, but the color changes, right? Now, if the price of Kaia goes um, down a little bit, the price, this token URI is meant to change, and the price, the emoji here will change to sad, right? And so on and so forth. So this is the idea of dynamic NFTs, right? So let's take a look at this in practice, right? So now that we have deployed our contract, um, now let's interact with our contract. So while I was putting up this guide the last time, I added the image, right? At the time when I deployed the last time, it was 0.20, which was happy face, right? Now let's try to interact with the deployed contract. Now Foundry provides us a functionality to interact with the deployed contract using cast, right? So what we need to do is to use the method cast call if you are trying to read from the blockchain. Now, if we're trying to send or mutate the blockchain state, we use cast send, right? I hope that makes sense. Now, these are the 3 functions we'll be interacting with. First, let us get the current price of Kaia, right? So all we have to do is to copy this command and run that in our terminal. So I'm just going to paste this here because I need to change the contract address uh, to the new contract address. I'm just going to copy this and paste here. And so all I have to do is, in your case also, you have to change the address over here. And all you have to do is just clear your terminal and run the command one more time. And so we're supposed to get an hexadecimal, right? So this returns an X. And to convert this X to decimal, right, let's go to rapid tables, X decimal converter. So what I'm going to do is I'm going to paste the value there and convert. So it says 0.19940,465. Now this is the current price of Kaia as provided by Oracle Network, right? So are we seeing how that Oracles provides us the functionality to fetch data off chain and bring them on chain? Now, in my smart contract, I'm able to get the price of Kaia and I can do whatever thing I want to do with it. And so in this case, we are building a dynamic, or we've built a dynamic NFT, right? Now, having done that, the next function to call is the last price. Now, this last price is the last price of Kaia when I originally minted, right? So the next thing to do is to copy this command also and just change. So because we are still reading from the blockchain state, we are still using cast call, right? Cast call, the contract address, the function name, and the RPC URL, right? So I'm going to copy this command and click enter. So this also should return an hexadecimal, and I'm going to also convert that to decimal. So the last time when I minted, it was 1987563. If we check, it was 1987563. So that means that if I try to update my SVG right now, my SVG should change, right? It should change color, and hopefully it should change the emoji. So let's do that. All we need to do is just go back to the deployment guide and call. So to reflect our change in the NFT, we have a function in our contract called update SVG. Now, so the update SVG function is a function you need to call for it to listen to the change in price and basically just update the token URI, right? So that is why we are calling the update SVG. So from our formula or from our command, we need to use the cast send, the RPC, the contract address, right? So I'm going to paste this over here. And also the function you're trying to call, which is update SVG, the parameter type, and the argument. Now, in our case, the argument is 0. How did I know that it's 0? In my token ID, it says 0, right? So having done that, also, I'm going to put the account and my account name. So I have to change this to expampam dev3, right? So I'm going to copy this and just paste in my terminal. So I'm expected to put in my password. And as you can see, the status is success. So this went through. We were able to update our SVG. It went through. It was a success. And so that means that we've updated our token URI for our NFT. Now, as you can see, it's currently not showing, but all we have to do is to refresh our token URI, because now our token URI has been updated based on the current price. Yeah, I hope everyone is following along, right? So yeah, so once we refresh, right, as you can see, it says token URI has been refreshed. As you can see, the color changed to green from yellow, although the significant change is when there is like a dollar change. Take for instance, by 1 unit, it moves from 0.9 to 0.20, or from 0.20 to 0.21. Then this is going to change the emoji to happy or sad. Now, if this moves from 0.19 to 0.18, this emoji will move to sad, right? Because that's a significant change in price. So this is how we have encoded the logic. So that's pretty much about dynamic NFTs, where NFTs react to events outside of the blockchain, especially in the real world, right? So having done that, now that we have deployed and also interacted with uh, our NFT, right? The next thing to do, as you can see also here in this guide, the color changed from yellow to green, right? Pretty much. Now let's verify our contracts. Now, why do we need to verify contracts? We need to verify contract because of transparency reasons, right? In the case where you want your source code to be open to the public. Before then, do we have any questions or yeah? Do we have any questions so far? So I can just take them and just proceed. Please, can we just drop a message in the chat just to confirm if you don't have any question or if you don't have any question? All right. So yeah, I'll be keeping a look, or I'll be keeping an eye on the chat. All right. So why do we need to verify a contract, like I mentioned? We need to verify our contract because of transparency reasons. where you want your source code to be publicly available to everyone. Now that we've deployed our contract, if you check on Kaia's Kairos scan, the only person that can access my contract is myself, the deployer. As you can see, my contract is not publicly available, right? My contract is not publicly available, meaning that nobody can access my contract code except for myself, who is the deployer. And because I'm the one that deployed it, I have the code base. But in any case, if we want our contract to be publicly available to the whole public, right, for transparency reasons, how do we do that? Now, this is where verification of contract comes in. Now, for the most part, the first thing we want to do is to flatten our contract. Now, when we say flatten, it basically means compiling your contract into one contract. So let me explain that in just simple terms. As you can see, my dynamos.sol have various imports. OpenZeppelin import, ifeed proxy import, and all of those things. So we need a way for it to be compiled into one single contract, right? All of this contract code needs to be compiled with the dynamos.sol, or the dynamos contract needs to be compiled or needs to be aggregated as one. So this is what flattening does. It basically helps us aggregate our contract code in the case where we have multiple imports as one, right? So all we have to do is to run the command forge flatten the location of our contract and where we want the flattened contract to be. So you run forge flatten the location of our contract and where you want your flattened contract to be. I'm just going to copy this command and paste over here. And as you can see, we have flattened dynamos.sol, right? So all of my import file, all of my contracts has been outputted as one single file, right? So when we are verifying, this is what we'll be verifying in our smart on the block explorer, right? So as you can see, it also has the Dynamos contract, which is this guy. And also it has various imports file that we have here. And so now we have a single file that has all of the multiple imports and also our Dynamos contract, right? I hope that makes sense. Now, once we are done with that, the next thing to do is to run the command forge verify contracts. So I'm just going to copy this command and explain it one after the other what we are doing under the hood. Okay, so now the first thing to note is that we are calling forge verify contract command, and then the verifier URL as provided by Kaia scan, we are also imputing that, which is like the endpoint for verification. Then we are saying the chain ID of the of where the chain is, of where the contract is deployed, of course, is Kairos testnet. Then the constructor argument, right? Now, in our case, we have constructor argument, right, which is the price feed address. So we need a way to also pass this in when verifying. So to do that, I also have to change this address over here to this contract address. So all I have to do is to change the address. And once that is done, initially when we compiled, you said that we are compiling using 0.8.30, compiler version 0.8.30. And I mentioned that that is really important because it is what we'll be using as the value for the compiler version flag, right? And so in this case, we're using compiler version 0.8.30 with the commit and the hash value. And once that is done, okay, I think this part, I missed it. We have to put in the Oracle feed proxy contract, right? Because that's our constructor argument. In this case. And then, so that would mean Just copying this guy, which is the feed proxy. And so I'm going to copy the contract address itself and paste in the contract address field, which is this one here. All right. So once that is done, we also have to tell it that this is the contract we are deploying. In this case, it is the flattened dynamos.sol dynamos, right? And the number of retries is just one time. So I'm just going to copy this command and paste here. So as you can see, it says start verifying contract deployed on 101, compiler version 0.830. Constructor argument is this guy. Submitting verification dynamos, contract successfully verified. So we have successfully verified our contract, right? What this means is that now our source code can be publicly available. As you can see, it changed from not being available to being available. And we have the verification ticker over here, right? As you can see, now we have the custom ABI, we have the various functions, actual color, balance of, uh, we can now directly interact with the contract from the block explorer, right? Latest price, uh, the name, and also the owner of, if I put 0, I can query, this is the owner of NFT with token ID 0, which is myself. And so that's pretty much about verifying your contract and also building a dynamic NFT, right? I hope I've been able to do justice to, building a dynamic NFT and also bootstrapping your Foundry project from scratch and also deploying and verifying your contract for transparency's sake. All right, so I think that will be all. One of the things that we can also do also is to later on, once the price of Kaia increases, maybe to 0.5, you can go and update the SVG and just see how the token or the emoji would also change. Of course, it will still maintain the happy face and the color would also change, right? Because we are randomizing how the color is regardless of the price, right? So that's pretty much it. Bless me. So for this session, I don't have much task. This is just on light mode, or me imploring us to explore other oracles integrated on Kaia. Take for instance, all you need to do is just to take for instance, go to Pyth Network documentation, uh, and explore their uh, price feeds, right? Entropy, right? Which is basically getting random numbers, right? The next one is super oracles. You can also explore this one and how to integrate them by just going to the documentation, decentralized VRF, data feeds, and yeah, and also Witnet, right? You can go to Witnet and explore how Witnet is also implementing theirs. They have various guides, right? So you can just explore um, how all of these things work, right? How to guides, and yeah, pretty much it. Once that is done, moving back here, you can either try out, the VRF function, right? How to implement VRFs in your contract. Probably by randomizing our dynamic SVG traits, right? And so the next thing you want to do also is to deploy and verify your contract, as we've done in this same session on Kairos testnet. And once that is done, you might choose to share on Discord, right? So this is just light mode task because I know we still have a task from the previous session, right? And I'm rooting for everybody to complete our assignment, right? I think that'll be all for today. I hope I've been able to do justice to uh, integrating oracles into your smart contracts. And so far we've seen how oracles are important, how that they help you, build decentralized hybrid application and opens up your smart contract to a lot of use cases. The different types of oracles from software oracles, hardware oracles, pull-based oracles, push-based oracles. We also have centralized oracles, decentralized oracles, and also inbound and outbound. Then we talked about the various oracles on Kaia, how that we have Supra oracles, Oracle Network, Pyth Network, and also WaitNet, right? And the major Oracle services that they provide, data feeds, especially price feeds, and also verifiable random functions. And majorly in this session, we deployed or I explained how to build a dynamic NFT that reacts to the price of an asset, in this case, Kaia. So we expect the NFT to change based on the price movement of Kaia. And we've seen that in practice. Then we moved on to initialize our Foundry projects and also deploy, verify, and yeah, pretty much it. Thank you all for sticking through till now. I hope to see you guys on Discord and also, exploring the light task that I gave. Right. So yeah, thank you for your time and let's keep building. Right. If you have any
Yeah.
question, I think you can put them in the chat also.
Yes. So thank you, Ayo, for the very nice summary. And yeah, so if you have, as Ayo mentioned, if you have any questions about today's session, please do put them in chat. Or if you are brave enough, you can also raise your hand and ask your question live. As I mentioned previously, it is something that we do very much prefer. There is no need for you to turn on your camera, even though it is encouraged. The reason why we prefer you guys asking a question live is because a lot of times there are follow-up questions from ourselves. Like for example, like you asking a question and like which one were you referring to? So if it's live, then it's easier for you to respond quicker. But we will probably give it another minute or two just to see if there's anybody typing in chat away, because sometimes questions might take a bit to type out. Yep. So while we're waiting on that, as I mentioned, about halfway through, about probably an hour ago at this point, a bit more than an hour ago, there will be no sessions next week. This is because we will be taking that time to do up all the attendance criteria and stuff like that. Even though there are two more sessions left, I think it's a good time to just do up who is eligible for the hackathon as of this current lesson. Because even though the final lessons are 2 weeks away, I think it's still a good time just to see and check, because realistically, if you are attending, if they've attended about 90% of the session so far, I think it's a very high chance that they would attend the remainder two, right? So yes. So if there are any further questions after this lesson ends, please do feel free to tag it in Discord under Bootcamp questions. And I think Ayo or our ambassadors are there, and they will be happy to respond if they can. I think Ayo can definitely respond. So yeah. If is there anything else you'd like to say, Ayo? I know you've already said your final words, but just checking. No, okay, cool. And I don't think we have any questions. So yeah, for those of you who aren't aware, I think this is also Ayo's last lesson with us. The next two lessons will be handled by back to Neo, as well as will be, I think, Aiden, and there'll be a new face, Ashwani, who is our head of ecosystem, who will be present. Our next lessons will be on, I just saw this, will be on AI and software engineering. They will be handled by Neo and Aiden. And then the final lesson will be on the actual Kaia ecosystem and career paths. So in that lesson, will be in lesson 12, which will be in 2 weeks' time. We'll be exploring Kaia dApps, building mini dApps. We'll be also having a live session with the mini dApp teams, dev teams. So I think this is actually the very first time we will be showcasing the Minidev SDK live open to the bootcamp participants only, because the Minidev SDK is actually closed off due to Line's privacy policies. So we will be showing off a live session we'll have a live session with the Minidev dev team, just for you to ask any questions or anything you want to bring to the table. That session will also be live streamed. So I think that's something that we're still in discussion with. Yeah. We'll also be going through the developer tools landscape, as well as any grant opportunities and application processes. And then finally, the actual career paths in the Kaia ecosystem, not just with the foundation itself, but with the other like dev teams, like our partner teams, the companies we have partnerships with. If you want to go to like, I think Supra, or I think a lot of these companies are looking for actually devs who are willing to help out. So yeah, and then we'll end it off the following week in 3 weeks' time with the mini hackathon. I think during that time also we should be launching around it will be around mid-July. We should be launching our own stablecoin summer hackathon. That's something that we haven't necessarily announced publicly, but because you guys are here, I think it's quite good to have like just a quick teaser. We don't I can't exactly tell you too much info. I guess I can tell you about mid-July, mid to end July we'll be launching it. So a big teaser here. So don't worry. After you finish the mini hackathon, you can go ahead and participate in the main hackathon as well, because I think it will still be happening, right? It should still be happening at least, because the idea is the mini hackathon will end and then you can go on to the full hackathon that is launching, I think mid-July or something, like if nothing gets pushed back again. Yeah. So hopefully you all, I think everyone here should be eligible that is still here, at least. I do hope, and the recordings and slides should be out, I think latest by tomorrow. Time zones are weird. I know it's about 4 o'clock, almost 4 o'clock in Africa, like in Nigeria, right, in West African time, but it's almost 11 p.m. here in Singapore. So I will try my best to get it uploaded by today. Oh, I've already taken a screenshot for you, Ayo. Anyways, yeah, okay, I'll do my best to get it uploaded by today, and then all the slides as well, are super easy to do, so you guys can review it. And I hope that everyone was able to follow along. And I know there's some times where it can get a bit fast, and I did get lost a bit halfway through. So I will be reviewing the video as well as I am editing the video. And I think yeah. So if there are no questions, I think we can just end it here. Yeah. So. Yep. All right. We can end it here. And yeah, take care, everyone. We'll see you all in 2 weeks. As I mentioned, there will be no lessons next week because of ECC, as well as we're taking the time to review all the attendance policies and to see who is eligible for the hackathon. Yeah, and obviously we may need to form you guys into teams. You guys, like I said, I will be sending out a questionnaire to the Discord to check if I know that some of you guys already have, like, you guys are friends. You guys have been talking over the past 2-3 weeks at this point. So if you guys want to form your own teams, that's fine. But I do know that some people may still be a bit shy and stuff like that. So if you would like us to help you form into a team, I think we will help you as well. So yeah, as I mentioned, if there's nothing else, I think we can just end it here. And yeah, take care, everyone, and we'll see you all. I will see you all in 2 weeks. I think Ayo will still be lurking around in the chat in 2 weeks' time as well. He'll also be on Discord if you want to ping him. Yeah. So yeah, take care, everyone. Okay, bye.
All right, bye.